Howard, how are you doing?
Pretty canny, mate. How are you?
Yeah, not too bad. So we're going to do a little bit of tube fitting, is that right?
Yes, me big 8-horse Wallace.
I'm looking forward to it.
Yeah, good stuff, good stuff. Open the door.
I see you've already had a good start.
Yes, I've got...
But you've left a few for...
there's 30 tubes in total.
Yeah.
I don't know how many we've done there now, but we're best part of the way through.
Yeah.
So, yeah.
Right, let's get you started. I'm looking forward to it.
Brilliant.
Excellent.
Nice one.
This wonderful creature here is a Wallace & Stevens 8 horsepower agricultural traction engine, and it's having some major boiler work done on it, some major repairs. I was here a few weeks ago and I did a little bit of riveting, and today we're going to be putting some tubes in. But I'm going to go around the boiler and explain what the different parts are, how it works, because you don't often see one like this that's all stripped down without its clothes on. It's interesting the way it's been done. They haven't changed from this in 1908 until the last of the steam trains. The boilers are exactly the same, work exactly the same way. We've got a thing here called the firebox. Obviously where the fire goes, that's surrounded by water, and you've got your boiler barrel, and there's tubes that go through the barrel which will show in the heat and hot gases go through the tubes, and that's what boils the water. The more hot bits in the water, the more it'll boil, the faster it'll boil. Up on top, that's a steam cylinder. It's a big single cylinder, 8 horsepower, big, slow revving, loads and loads of torque. This will be used for will be used for threshing. Run a sawmill. With having such a big firebox, you could run it on waste wood, no problem at all. I'm going to start at the firebox end. These are the rivets we put in the last time I was here. What you've got here is 2 skins of metal. Between the 2 skins of metal, you have water. So the water is heated by the coal burning inside the firebox. These threaded holes are for steers. They're bits of threaded rod that screw right through the boiler to hold the 2 sides together against the steam pressure. Without them, it would swell up, it wouldn't be able to stand the pressure. So they're what they call steers. They're screwed in, then riveted over. That's something we're going to be doing a little bit later on. There's a hole here, that's for a clack valve that puts water into the boiler. These are called horn plates. That's where the engine crankshaft goes through there. All big, massive, immensely strong stuff. I'm going to have a look inside the firebox now, see how that works. This is the rear of the boiler. That's actually the fire hole. That's where you put the coal in. That's part of the water jacket as well. And the tender would go on here. That's where you stand to drive it. All the equipment on the back of the boiler's there, and where you carry the coal. Like I say, that's drilled, and it's drilled on the inside as well. We'll go inside and have a look. So you've got a water jacket filled with water, obviously, and you've got the fire inside. So all this heats up, heats water. We'll have a look through here, and you see the actual tubes that take the heat, the hot gases through the boiler. This is obviously just a bracket that's been built to hold it, to make it work, so you can work on it. It's ideal the way they've got it jacked up. Really is a nice setup. Right, so I'm going in through the fire hole door. That's where you would shovel the coal in. And you can see the tubes in there. If you look on the side of the firebox, you can see the steer holes as well, where they're threaded all the way through. The big bolts on the top hold the bridge steers in. We've still got the top 2 rows of tubes to put in. If you look up there, there's a brass plug there, or a bronze plug. That's called a fusible plug. It's got a hole right through it, and it's actually filled with lead. So you can imagine you've got your big fire roaring in here, and if the water level drops too low and exposes the top of the firebox, it melts that lead plug, and steam and water rushes in and puts the fire out. It's a safety device. It just works. There's nothing to go wrong with it. No batteries to go flat. It just works. It's been used forever, and they still carry on using it. This is looking up in the bottom of the firebox. You can see on the side, that side, look at the gap between that plate and that plate. That's the part that's filled with water. Tube plate, and the fusible plug. Moving along from the firebox, we've got the actual boiler barrel. That's where the clack valve goes, there's a pump up there, and that pumps water into the boiler. You can see the boiler's had some repairs done because it is obviously very old. There's been a patch put in there. This boiler, when it gets put back together and it's all sealed up, will be hydraulically tested to 1.5 times its safe working pressure. That happens every 10 years, and every year it also has a visual inspection and a steam test. This has got to happen. It's the law in the country. It's the only way you can get insurance for a steam boiler. On top of the boiler, we've got the steam cylinder and the valve chest and the motion work, link rods for the valve gear. That is a brake for the flywheel. That big bearing there, that's where the crankshaft goes through. Flywheel is mounted onto here. That thing at the end, a water pump, as a pipe comes down into the clack valve, pumps water in. There's a bracket up there, that's a steering bracket. The steering rod or steering shaft goes through there, down here, and it drives a big roller with 2 chains on. Moving forward from the boiler barrel, there's a row of rivets here, and that's where the front tube plate goes. So all this part and the firebox is completely under steam pressure, and the water level is probably about there, covering the top tubes and covering the top of the firebox. This part here is a smoke box. Where the smoke goes, where the chimney blast pipe is, we'll come round, have a look inside of there. Moving on to the front, we've got the smoke box door. Inside the smoke box, you can see the tubes coming through the front tube plate. The bottom ones are in and expanded, and we're going to be doing some of the top ones a little bit later on. This is where all the ash collects. See the products from combustion come through there, up the chimney, the blast pipe, blasts, puff, 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 and that's what draws the fire. Like I say, that's what makes the steam engine go chuff. That's the blast pipe going up the chimney, exhaust steam is blasted out of there, that's why it's called the blast pipe. Smoke box is an ideal place to put a nice heavy cast iron pot with a big joint of beef in, wrapped in tin foil, cooked slow all day, absolutely splendid. These holes in the bottom of the firebox are what they call mud holes. There's a little door that goes in there, which is strangely called a mud hole door. You take these off to wash out and clean the boiler, which must be done very frequently because it do build up a corrosion and sediment. This is the rear of the firebox. I showed it earlier on, but I didn't show this. It's had a patch welded in all the way around. Quite a common repair. See the material there, that must be a good 5/8 of an inch thick, 15 mil. There's still rivets to go in the corner. They're a special rivet because they're a blind hole, you can't get in behind them. This is the front axle. This is called a perch bracket, where the front axle pivots. You can see there's some bits missing. I mean, the engine is 120-year-old nearly, and it's obviously got a lot of history to it, so that's probably been damaged in an accident. It's a close-up of that broken perch bracket.
The way it works is the holes in this end, in the smoke box end, are slightly bigger than the other end, because when you come to draw them out, and if they get all rusted up and that, you kind of get them drawn out. So these ends here are a little bit bigger. Company up at Prudder Salem Tubes, you'll order them to length, and they'll actually swage one end, so it's a wee bit bigger, you know. It makes life easy, but
unfortunately that'll be this end.
Yes,
slightly bigger.
This end slightly bigger, so you'll order them to length and swaged, give them the dimensions exactly, and they'll make it. Unfortunately, these buggers are too big. They didn't actually have a swaging tool.
Oh right, so you've got to improvise to do it.
So, and you could put them in and do it by hand, but they're about 3 mils to expand,
right,
and it's hard going. So what I've been doing is basically pre-expanding them actually on the lathe. Makes life a bit easier for us, as it were, like, you know. So the procedure is the holes in there, it's best to linish them, basically polish them up so that they're almost a mirror finish, both ends. The tubes then in the lathe again, just with the emery tape. I'll linish them up so that they're really shiny, so the mating surfaces are really bright.
So there's nothing goes between the tube and the...
Absolutely nothing. No, no oil, no paste, no nothing. It's just a
really tight, expanded job.
Polished finish so that you get no rust in between them and stuff, you know. And then obviously expand them real tight. You'll see when we do it.
Yeah.
What I've also been doing as well is just expanding yon end.
Just a little bit.
Just a little bit. It just takes the elbow grease out of it.
Away,
yeah.
How long are they expected to last?
Well, do you know, it's a funny thing that if you're putting boiler treatment, it depends on how much you're using and
obviously,
how much of a hard time you give them. But if you're putting boiler treatment in, you should sort of expect to get maybe 20 years out of them, you know. However, there's some horror stories recently about poor quality tubes, and they're not lasting 5 minutes.
This is proper seamless stuff for the job.
The seamless, what they call cold drawn tubes.
Is it all certified for the tubes?
Absolutely, the boiler man needs it, and as I say, this Salem tubes up with Prudder, they'll give you the.
So you've got all paper work, it's all paper trace.
Absolutely, If you allow a quarter of an inch sticking out at this end, and an eighth of an inch at the other end.
Right.
But you're honest, these are massive. These are 2.5 inch tubes, you know. Yeah. And so I've just put like a quarter of an inch either end.
So that's quarter of an inch pro to the.
That's right. Yes. Yeah. So as I say, we'll get one addressed up. So what I'm doing, I'm going to put a tube. Well, we'll linish out these first of all.
Yeah.
I'm going to put a tube in. We'll get it marked up for length. We'll get it up on the lathe. We'll part it off to length. We'll expand the firebox end just a little bit, just to give us a bit hand. We'll polish it up, and then we'll expand it in.
Yep. Okay.
See how we go.
Excellent.
All right.
Yep.
Good stuff. That's coming in nice, isn't it?
Yeah, you can see it's good finish here.
Nice one. Right, same again on the inside. So this is where my other tube comes in handy. There we go. So you should have a canny bit stuck out at that end now.
Yeah, it's quite a bit stuck in there.
So as I was saying, I'm going to try and set this up so there's a quarter of an inch in here. I've just got this lump of plate that I'm using as a gauge. Right. So I'm just setting that up like that and checking that's about spot on. Actually, got lucky there. Cool. Good.
You can see how it's got an essential piece of safety equipment on.
You know, you absolutely must have your cap on because I'm pig sick of hitting my head on the underside of that. So there you are.
It's amazing how much difference a little cloth cap makes.
A little cloth cap, and I tell you what, it doesn't half save you.
It does, aye.
Anyhow, right, so as you can see, we've got this tube sticking out a fair bit. So I've got a couple of bits and pieces here. I'm just going to put a bit of chalk on there so I can see what I'm doing.
So you obviously got these cut longer, so you mark them yourself and cut them to spot on.
That's right. It's just, as I say, there's a little bit of variation between the lower side and the top side, and just to keep it sweet.
It's kind of measure twice and cut once.
That's right. Yeah, and I've got my bit plate again. Yeah. So I'm just going to scribe that off. So I know what I'm doing. It's going to be a bit awkward doing the top ones, but we'll worry about that when we get there. water out straight, that the roller there is ever so slightly angled.
Yes. Yep, it has got a lead on it, yeah.
And in essence, as you wind that, as it goes further in,
it pulls it in.
It's pushing that. It's pushing the rollers out over, which expands the tubes.
And it's actually dragging that.
There's no screw threads or anything on it. It's not rifled or anything like that. It's just it sort of naturally draws it in. And then what happens is, as this is turning, it's got no resistance, so you can't see, but I don't know if I can do it on there. As it turns, can you see how the rollers?
Yeah.
The roll around. Now obviously will be up, but in essence that turns, this gradually goes in
and it swells the tube.
And swells the tube. Strictly speaking, this bit here is actually supposed to go the other way around, and the idea is when you're going up to the tube plate, this gives you a spacer up to there, but because I'm pre-expanding this in the lathe, this is getting in the way, so I've just swapped it round. I've made a little collar to go on it, so that basically does the same thing, but as I say, strictly speaking, that's supposed to go up against the tube.
It's the opposite way around.
It's just I need to get the verniers with caliper on here just to sort of measure it, and with that in the way, it was causing us a bit of trouble, like, you know. So I've swapped it around the other way.
So obviously you've done a few, so you know how big it's got to be now.
I'm taking that to 65 mil. So we'll see how we get on. So as I say, I've just done it this way. I'll show you in a second. But I don't know if you can see that, but it's actually drawn this mandrel into it.
You can, yep.
And expanded it up. I don't want much, but every turn that's happening here is saving me.
Doing it by hand, yeah.
Doing it by hand in the obviously I couldn't have gotten the caliper on if
that was the other way around.
If that was the other way around. Right, well, I've got that spot on again. Right, so this is, I'm just using as my gauge to get the distance out okay, but obviously I'm going to start on the on yon side, but currently there's nothing really stopping that
from turning.
Yeah. So we'll just keep that on there. Right, now that's not moving, so I can get a start with
yeah, and once you've expanded that side, obviously that'll stop it turning when you come to do this side.
Absolutely, yeah. Some people don't bother oiling these and just run them dry.
Sounds strange to me.
It does, you know. Especially if you retighten them, there's a bit of rust on, they pick up all the crap and it goes in, but these are brand new tubes and everything, so a bit of lubrication, I cannot see any reason why you wouldn't.
It's just a bearing, really, isn't it? Like you tape a bearing.
In essence, yeah. Yes. Yeah, and as I say, it's just expanding. If you actually get in close when you first see it, you can actually see the steel like undulating as the rollers are going round, and it's quite weird.
Till it gets a grip on it.
Till it gets a good grip, as it were. You know, it's surprising the power they have, like, you know. Right, so this is the one we've just put in. It's obviously that's cut and measured. It's worked out okay. So expander in, as I say, my little collar's stopping it from going too far up. As you can see here, normally this
That would be the other way around.
That would be the other way around. That would stop it from going out too far, but like I say, it's a slather
using
on.
it for something else. So.
Yeah. That goes in there. I've put a socket on the end just so I can...
So this time, instead of the tube turning, obviously you're turning the actual spindle.
Correct, yeah.
And that'll just pull itself in and expand the material.
That's right, yeah. So it starts off pretty slack till the mandrel starts working its way in a little bit. I'll start to feel a little bit of tension on it there now. So it's going in. Some people go to the gym to do all this, John. You can do it here for now.
Absolutely.
Get the canny grip there now. So as I say, usually if the hold water cold, it'll hold water hot. Yeah. And indeed with this, with it being a brand new firebox, brand new everything, it'll be hydraulic. So it'll be took up to 1.5 its normal working boiler pressure before it's been heated.
What is its working pressure?
It's 120 psi.
120, yeah.
So
take it up 180.
That's right.
Yeah.
So as I say, that's really quite a cruel test for it because it's not getting the benefit of getting the heat expanding it.
Yeah.
So as I say, usually if it holds water cold, they'll hold water hot. We have had problems with sort of tubes leaking over the years and you can just nip them up, but what you generally, like if that one leaks, if you expand that one, it sets the ones away around it, so you end up having to do the whole bloody lot, like, you know. But I'm sort of optimistic that these will go in, and not with them being brand new, you know, they're nicely polished up and all the rest of it. And on top of that, quite honestly, it'll be some months before we actually get water in it because I've got all these stairs to do. A little bit of corrosion, sort of, it'll sort of take it up a little bit like and give us a better chance. Right, we'll get the other end then. So get it out, same again, just. So same again here, however, I've just made a bit of a contraption. I'm using the extension so that I can work out of it. Yeah. And I've just cut a bit of wood just to rest it on so it's not pulling out a square, you know. So again, obviously if I was doing this inside, that would make my life a lot more difficult.
You actually see the tube you fold it.
It's weird, isn't it? You know, it's like it's
you can see it moving.
It's like something's growing inside of it, which it actually is.
Oh yeah, it's closing that up there very nicely.
When I've got you usually have the big halogen lamp down yon end shining down the barrel, and you can sort, if you get your eye right, you can
see the crack.
You can see it close up. Now it must be up somewhere now because I start to get a bit of weight on it. And as you can see, because I've pre-expanded them, I've got very, very little to take up. Yeah. So it makes my life easy.
You've let the lathe do the work.
Absolutely.